Okay, let's jump right into this explainer. Today we're unpacking a massive multi-million-dollar decision facing pretty much every management team looking to update their 2026 manufacturing floor, the choice between fiber and CO2 lasers. Now, if you're sitting in the C-suite or running procurement, you already know that buying industrial machinery has fundamentally shifted. It's really no longer just about how fast you can cut metal, it's about safeguarding your entire operational strategy.
Because let's face it, in an era of ultra-strict ESG standards and super lean production goals, we have to look way past the shiny new tools. Our sole focus today is the bottom line and the actual operational realities. Specifically, we're hunting for the absolute lowest total cost of ownership for your exact product mix.
So, here is our strategic brief for today. We are going to cover the 2026 procurement landscape, technology and material match, total cost of ownership, supplier verification and sourcing, and we'll wrap up with mitigating risk and future trends. Starting with Section 1, the 2026 procurement landscape, framing the stakes for ESG and lean production. Right out of the gate, to make a truly informed buy, you absolutely have to understand how the power source dictates your factory's footprint. Fiber offers this incredible industrial durability because it relies on a solid-state laser source, which is delivered via flexible fiber optic cables. CO2, on the other hand, well, that's a much heavier logistical lift. It requires an electrical discharge to excite a specific gas mixture, carbon dioxide, nitrogen, and helium, and then it channels all that through precision-aligned mirrors. So you're essentially committing to consistent access to high-purity gases and highly specialized calibration right there on your floor.
Moving to Section 2, Technology and Material Match. Remember the golden rule here. The material dictates the machine.
Fiber lasers operate at exactly 1.06 microns. Now, why does that specific number matter to you? Because this incredibly short wavelength is rapidly absorbed by metallic structures, and that is what unlocks ultra-high-speed metal cutting.
So if your procurement team is sourcing for automotive, aerospace, or even kitchenware, fiber is absolutely your undisputed go-to for managing metal fabrication. It easily chews through highly reflective metals like copper and brass, completely eliminating the risk of back reflection damage, which, as you probably know, historically plagued those older CO2 systems.
Now, flip the script. CO2 lasers operate way up at a 10.6 micron wavelength. This makes it a highly specialized niche tool, simply because this specific wavelength is absorbed exceptionally well by organic materials.
Meaning if you're sourcing for high-end furniture, packaging, or signage, CO2 is still completely indispensable. It provides a gorgeous flame-polished edge on acrylics that a fiber laser just literally cannot match. In fact, tons of high-end brand owners still explicitly specify CO2 cutting for leather goods just to avoid the intense charring a fiber beam would cause. For organics, it's an absolute aesthetic and labor-saving necessity.
All right, Section 3, Total Cost of Ownership, where we pit CapEx against OpEx for 2026. When you lay these procurement metrics side by side, it becomes glaringly obvious that the initial sticker price is often the least significant variable in your equation. Sure, the initial CapEx for a high-power fiber unit is definitely higher than an entry-level CO2 system, but you have to look at the operational uptime. Fiber cuts steel up to 5 times faster, and its maintenance interval is a staggering 20,000 plus hours. Compare that to just 2,000 to 4,000 hours for CO2. Over a 5-year horizon, your cost per part just plummets with fiber.
And speaking of costs, let's talk about energy volatility, which remains a massive global risk. Look at this disparity. Fiber lasers boast a wall plug efficiency of up to 45%, while CO2 hovers around a mere 8 to 12%. Honestly, switching to fiber acts as a literal hedge against rising utility costs. You're consuming significantly less electricity while actually pushing out higher output. Then there's the universal law of the factory floor. Maintenance literally equals downtime, and downtime is the enemy of ROI. Fiber has 0 internal moving parts in the laser source and no mirrors to clean. CO2 systems, however, demand periodic gas refills and highly specialized mirror replacements. If your facility is in a region where specialized laser techs are harder to find than a good cup of coffee, well, fiber is the hands-down winner for operational ease.
Okay, Section 4, Supplier Verification and Sourcing. How do we actually execute this buy in 2026?
Look, a machine is only as reliable as its weakest integrated part. So your procurement checklist needs to demand specific top-tier brands. Verify the source. Is it a trusted name like IPG, Enlight, or Rakis? Check the head. You really want to insist on brands like Precitech or Ray Tools that include crucial features like autofocus and active collision protection. And please, never overlook the motion mechanics. You absolutely need precision ground rack and pinions from manufacturers like Atlanta or YYC.
And here's a massive insider tip. Look right past the shiny exterior of the frame. You have to verify that you're dealing with a legitimate original equipment manufacturer, not just some trading company in a trench coat. The best way to do this? Request a live video audit. Demand to see their temperature-controlled clean room for optical integration, and literally watch your actual machine undergo its 72-hour stress test before it ever gets packed in a crate.
We also can't ignore the digital side of things. In 2026, smart factory compatibility isn't some luxury add-on, it is a hard requirement. Your laser software, whether that's Sipcut, Lantec, or Beckhoff, has to seamlessly talk to your existing ERP and CAD/CAM systems. Modern procurement heavily favors this kind of interoperability because it prevents massive bottlenecking on the factory floor. Finally, Section 5, Mitigating Risk and Future Trends. Let's protect that investment.
To execute flawlessly, you'll want to follow a strict 4-step executive workflow to mitigate your highest procurement risks. We've touched on the audit and the software, but step 3 is absolutely vital. So many buyers import these high-quality machines, but then totally fail to train their local staff on optimizing the cutting parameters, which just bleeds money on consumable costs. Always lock in commissioning and training clauses. And finally, secure a 24-month warranty specifically for the laser source. It's your most expensive component, often eating up 30 to 40% of the total machine cost. Protect it.
Looking a bit further down the road, the absolute biggest trend disrupting the market right now is AI-integrated cutting. The top suppliers are rolling out game-changing features like nozzle health monitoring and auto restart. They use built-in cameras to instantly detect if a cut fails or if a nozzle gets damaged. Now yes, this AI integration definitely demands a higher initial CapEx, but it drastically severs your reliance on highly skilled manual oversight.
What does that actually look like on your floor? Well, thanks to that AI automation, a single operator can now effectively manage 3 to 4 machines at the exact same time. For senior management teams, this drives labor overhead down so dramatically that it fundamentally rewrites your entire ROI calculation.
So, I want to leave you with this final thought as you weigh your short-term budgets against the absolute necessity of long-term survival. Are you just buying metal cutting capacity for today, or are you procuring a system that's robust, efficient, and intelligent enough to dominate the rest of the decade? Thank you so much for joining me on this explainer.